Hey, how you doing? This is Walt from Raybuck Auto Body Parts, and today is day 14 of our 6-speed transmission swap. Actually, day 14 that we're filming, not actual day 14 of working on the car. The past week has been very frustrating trying to get the car on the road. I thought last week that I would have it on the road and be able to get some miles on it. The weather's starting to turn here in PA, get a little cooler, so I definitely want to get the car on the road before the weather hits, just in case there's anything wrong. Not that there should be, but you never know. So I'd like to get some miles on it. But some things have changed since previous videos. I changed the master cylinder on the car for the clutch. That was supposed to be a 3/4 inch master cylinder. I ended up going to a 7/8 inch master cylinder, and I also changed the type of reservoir on the car, so I ended up changing all that. What else did we change? Just a lot of frustration with the whole hydraulic clutch setup. I've never done one of those before, and this setup was a little bit different than like how a normal master cylinder is because it's on an angle, and I'll show you what I mean by that. So long story short, bled the clutch master cylinder in and out a couple times, tranny came out again. Just a lot of frustration with that, but I finally got it figured out, and I'll show you what I did with that and the problems I had with it. Okay, so before we get into the new master cylinder, let's take a look at the old master cylinder. Same brand. This is a Tilton master cylinder for the clutch, and it seemed to be fine, but for whatever reason there was a lot of, like, the pedal was going all the way to the floor. I know there was still some air in the lines. I didn't have it bled very well, but it wasn't even moving the throwout bearing. So I talked to Tilton. They did recommend going up to a 7/8. They felt with their 6000 series bearing that it needed a little bit more volume to move it. So I did that. The other reason I did that was on top of this one, I thought it would be better to have like a standard fitting as opposed to the plastic cup that goes on the new master cylinder that I have. But this crush collar kept leaking. I kept tightening it and trying different things with it. It just kept leaking. This piece that goes in the top of the master cylinder is aluminum, and I kept tightening it, and I was getting worried that I was going to strip that out, and it just kept having this slightly little leak. It seemed fine, then you would come back the next day and it would be wet on the bottom of it. So between the volume problem and the leak, I just decided to yank that out. What I ended up going to was basically the same master cylinder, but let's see that pretty well or not. It is a 7/8, same thing, a Tilton master cylinder, and you can see it has that much larger reservoir on the top. It's basically a plastic piece that slides over, has an O-ring in there, and clamps on. Along with that, I changed the reservoir itself and how that mounts. Originally I had welded a little bracket onto the side of the hinge here, and I had a round type reservoir, which that worked fine. But when I went from the master cylinder with the fitting to the master cylinder that has that that plastic adapter on it, this line, the line that basically goes between the two, would not fit anymore. So it would only work with this setup. So what I ended up doing was, let's see, you can see where it's bolted there. Just made a little bracket off the firewall, and that just bolts up to the firewall. Once it was all done though, I think I actually like this setup better, and it really did help out because this master cylinder, normally master cylinders mount like the brake master cylinder. They mount straight, the reservoir's, you know, straight up, the lines come out the side and at the bottom of the master cylinder. With the way that this one is positioned, it points nose down, and where the fluid comes in here comes in kind of at the side. So I followed all the directions in it that they provided, and I even called the company, and they didn't recommend anything real special as far as bleeding it. And I kept getting air in the lines repeatedly. I tried a bunch of different things, tried bleeding it from, you know, sucking air out of the reservoir. I tried, you know, putting a vacuum pump on the bleed line and like sucking it through there. I tried everything but a power bleeder. I don't have one of those, and I don't know, after bleeding this thing a million times, I didn't know if that would be the answer or not. I've talked to a few people who said the power bleeders do work very well, but I think it's the same thing. They work well, but I don't think it works as well with this master cylinder pointing down. I watched a few other videos that people had where they did a conversion into older muscle cars, and it wasn't necessarily this kit or this car, but it was in a Chevelle, and they said that they did in fact have to bleed the master cylinder again, as they said, even though their manufacturer didn't recommend it or didn't say it was necessary. They found that, you know, bench bleeding the master cylinder definitely helped. So what I ended up doing was leaving this reservoir and the master cylinder connected, and then the line that goes from the master cylinder down to the union where it connects to the clutch throwout bearing. I left all that connected and took it out as a whole, put it on the bench so that the master cylinder was level, bench bled it, and immediately, like, the pedal came back, and it was, you know, it was fine after that. Just a lot of trial and error doing that, trying to figure out, you know, if it was air or if it was, you know, stroke volume on the master cylinder. So once I got it all in though, I put it on the bench, bled it that way. You could see a lot of air coming out. Got everything back in the car, but you still have to connect the fitting. And you can't really see, you can kind of see the line that goes down that way. Once it gets about halfway down there, there's a union where it connects to the line that goes to the clutch. So basically all I did with that, once this was all bled, I got everything remounted, and I had a cap on that so that obviously no fluid could come out, no air could go in. And then what I did was I just loosened up the cap on the reservoir, and I opened up the bleeder line on the throwout bearing, so that when I disconnected that cap, fluid would just continuously flow through the line. There would be no chance for the air to come back in. And even though it made a little bit of a mess when you disconnect that and you're trying to connect it to the other line, fluid continuously flows out. And once I got that connected, I just let it run. I just let it keep running. I probably put fluid in the reservoir a couple times, and just to make sure, you know, as much as the air came out of the throwout bearing as possible. And then, you know, just the standard bleeding procedure, you know, just pump it up a little bit, you know, crack the bleeder, that type of thing. And after that, the pedal's perfect. Take a look. Probably not going to be able to tell very well from here. I mean, the pedal is firm. The larger master cylinder definitely, you know, made the pedal firmer, but I can, I don't have any leverage here, but I can definitely push it with my hand if I can get some force behind it. So it works very well now, and you know, should be good. But before, when I used to push on it, you know, this would almost, you know, this would move a lot farther. This is actually probably more pedal slop than anything right now, but the pedal's real tight, so it doesn't go very far before it gets pressure. The other thing I put in was a pedal stop. You can see that behind there. That was just like a stand I had for, it's like a little pedestal, and it's threaded. It was from something totally random that I had laying around, but it seems to work very well, especially with the stock configuration of the pedals. Up inside the dash there where the pedals mount, there's not really any room or anything I feel that's really strong enough to hold the pedal as a stop. I've seen where people have put something up there before and they welded brackets on and things like that, and you really don't realize how much force you're putting on it, and typically those things end up bending or breaking. The clutch manufacturer strongly recommends that you set the clutch up so that, you set the pedal up so that when you push the clutch in, a 1/4 inch after it disengages, it should be stopped. So this pedal stop I have kind of looks a little bulky, but I think I'm going to paint it black and probably won't even notice it back there, but it does a very good job of being a very positive stop for the pedal. So other than that, not a whole lot has gone on in the interior of the car. Like I said, the transmission had to come out of it again because when I originally put the transmission in, I was having some trouble getting this in. The transmission was kind of fighting me getting the clutch discs aligned, and I thought maybe I had the throwout bearing adjusted a little too close. They recommend the 1/8 inch air gap. So what I did was I just turned the throwout bearing back a little bit to increase that gap, and once I got everything in the car and got the pedal bled, I realized that before the pedal started pushing on the clutch fingers, it was like a good 1/4 inch or more out, you know, from the bearing body. So I decided to readjust that, which meant pulling the transmission out. And luckily it wasn't too bad this time because since I had been able to work the clutch prior to that, it was the clutch discs had fallen in line, and so that wasn't too bad. But it did create another evening of work pulling this out, adjusting that and putting it back in. Since, let's see, I don't know if we ever saw the underneath of the car. But we redid our cross member. This is a stock GM cross member that I have redone probably 4 times now for different transmission configurations. So it's been hacked up a little bit, but it goes in and out well, and you know, gets the job done. We got our drive shaft back. Again, that came from Denny's drive shaft, and that is their, it's a 3.5 inch nitrous shaft, so that is good for tons of power. Got our rear gear in. We went to a 370 gear. The car previously had a 320 gear in it, but because of the manual transmission and not having the torque multiplication of a torque converter, the 370 seems to be the way to go. Depending on what you're doing, it seems like people have gone between the 370 and like a 389 gear. Some people like the 411s, but I wanted to maintain some of the low RPM of the overdrive, so I didn't want to get too high on the RPM. Plus, this is a turbo car, so it will make up for a little less gear. The one thing that I was going to point out is where your drive shaft goes into your transmission. I was watching some other videos, and I noticed one video where this part of the yoke was way close here to the seal of the transmission, and the person who was making the video said that, you know, the drive shaft fit just perfect. Not that that wouldn't work, but you do need probably about an inch gap in here between like where the base of the yoke is and where your input shaft is, or output shaft for the transmission. Because as the rear end moves up and down, this drive shaft moves in and out. Now for my car, it's a, you know, solid chassis car with a 4-link, so movement is going to be minimal. But if you have, you know, a swing arm car or, you know, leaf spring car where the rear end may have a lot of movement, it's good to make sure that you have some distance in there, because if not, you could jam this into the back of the transmission, you know, cause transmission problems and, you know, basically just disrupt the whole drive line. I don't have my other drive shaft loop in. We have this one here, which is kind of built into the car, but before there was a drive shaft loop right here. So came across, went up around the drive shaft, but with the longer transmission now, that puts this drive shaft loop like right here. Not like up against it, but where it would go around the drive shaft, which is a little too close, because now you're basically around the, you know, the yoke. You want to be kind of further back. I forget, I know there is a distance, if you look at like a NHRA rule book, I think it's maybe 8 inches or something behind the yoke. So you want it like up in this area. I am going to try and get one in there, probably not before winter. That'll probably be something I do in the winter, because right now I just want to get the car on the road and just get some miles on it. Pretty much for the gears and the transmission, clutch, you know, they recommend about 500 miles. Not so much for the rear gear, but for the transmission and the clutch. So I'd like to get it out and just do some driving. So that's what I've been up to. As I said, I am probably about a week and a half behind where I thought I was going to be. So got some things to button up and get the car on the road. I am hoping, tomorrow's Friday, hopefully I can put in a long night tomorrow night and hopefully have it ready for Saturday. Super excited to do that. It's been a long time. I've been wanting to do this 6-speed conversion, so I'm really anxious to get it on the road and see how it all works. But so that's it. If you guys have any questions, please comment below. Thanks again for watching the channel. Make sure to hit the like and subscribe button,